So now we can just define the determinant of an arbitrary n by n matrix. The idea is you assume you know how to calculate the determinant of a n minus 1 by n minus 1 matrix. So if A is an n by n matrix with cofactor matrix cofactor matrix C. So in order to even talk about the cofactor matrix, that implies that we can calculate the determinant of a n minus 1 by n minus 1 matrix A. Then the determinant, so it's the determinant of A, so it's written det A, is given by, you can do A11 times C11 plus A12 times C12 plus, and you keep doing this until you get to A1n C1n. So you just do this. Or, again, there are going to be basically 2n different formulas. You get a formula for going across each row or each column. So this first formula I wrote down, this is the first column expansion. You can also go across, the first row. You can also go across the second row. Plus A22 times C22 plus A2n C2n. So the constant for the second equation I wrote down is the first subscript, which is always a 2. So that means all the entries here are coming from the second row. Okay, so here all of the entries are coming from, these are all coming from the first row. Here they're all coming from the second row. And you can continue this for all possible rows. So you can do this for any number of rows. So for example, you can do the last row, an1, cn1 plus an2, cn2 plus, and keep going, ann, cnn. So if you do that, so you can expand this across all possible rows. So this is like doing the nth, the last row. But you can pick any row you want, and there's a reason that we want to draw attention to this, because oftentimes it's convenient to pick a good row or a good column to expand across. But you can also expand across columns now. So now columns are indexed by the second entry, so we can, fix the second index. So now it's going to be A21, C21. So all the things I'm going to write down, their second entry will always be a 1. So this is expansion across the first column. You can expand across the second column. You should draw your attention that all these symbols I'm writing down, the symbols in front of the subscripts of the A's and the C's are always the same. You're multiplying corresponding things together. Okay, so you can also, so this is like going across the first column, second column, etc. So in other words, there are literally 2n different expressions you could use, which is actually very powerful because you have lots of choices, and so you can pick the easiest choice you can use. Basically, you can expand across any row or any column. Okay, so anyways, that's the definition. So the definition is you have to calculate its cofactor matrix, and then you basically just take the dot product of the first row and of each matrix, or the dot product of the second rows of each matrix, or the dot product of the third rows of each matrix, and so on and so forth. And that is how you calculate the determinant of a matrix in general.